All right, here we are for another episode of the New Stack Makers. Joining us for a conversation today is Ory Segal.
Hey.
Hey. Ory's fame came probably a long time ago, but most recently he was the co-founder and CTO of PureSec, which is now part of Palo Alto Networks. So, Ory, I'm excited to talk to you today, and we're going to do something a little bit different. I'm going to treat this like an interview, like I would do if I was reporting this story to write it in the news stack. And I'm doing that because you have some news today. And I thought it might be a good opportunity just to get the breakdown on what you're announcing and look for some context to go with it. And so the news is about your new...
Let's see if you nail it.
Yeah, let me see if I get it. Let's see if I get it exactly. I'm trying to here we go. So here's the headline. Prisma Cloud now secures apps with the industry's only integrated web app firewall, which use your acronym as WAF, API
Correct.
security, runtime protection, and bot defense platform. Now, there's a few things in here that I'm really curious about. And the first thing is, why are you calling this a firewall? What is this, 1998 or 2006? What is this with the firewall language here?
I can talk about that for an hour, but I'll make it short, the explanation. First of all, we refer to the module within Prisma Cloud as WAAS, W-A-A-S, which is Web App and API Security. Within WAAS, a part of the functionality is actually a web app firewall, a web application firewall, very different than what our listeners are probably used to, and we'll get back to that a bit later. But it also contains runtime protection for cloud-native applications. You mentioned bot risk management, denial of service prevention, all of which are very cloud-native centric. And again, we'll dive into that in a bit. But yeah, the word firewall is a bit outdated, but as you will see, the concepts that we are presenting here are completely new and for completely, new and modern environments.
I guess the terms change in meaning over time. I think we've seen that a lot. Like, what's a server anymore, right? We don't think of a server. And I guess a firewall is something similar in some respects. It has a different connotation now. What does that mean that it has for you now?
So firewall historically were something that you would probably place at the perimeter when you had a perimeter. And the purpose of the firewall was to be like a police officer, like a cop, essentially allowing the good traffic in and out and then blocking malicious transactions. Today, especially in cloud-native environments, there's no longer any perimeter. We breached the perimeter. We took, our assets to the cloud. Some of them are running on containers, which can be, ephemeral, serverless functions, which are even more ephemeral. And it's hard for us to build a perimeter around those assets. You have clusters coming up and down, being deployed in one region or another. Some of the workloads are running in your, private cloud or on-prem. Some are in public clouds. And so deploying a firewall, the traditional firewall in the, legacy, traditional sense of the word is no longer possible. You need to come up with a new, novel approach, which is what we try to do with the WAAS module for Prisma Cloud.
So tell us about the WAAS model a little bit. And so what is behind this firewall? Tell us about the technology architecture that you've developed.
Okay, so when we came to build WAAS, we faced the three major problems or challenges that we tried to solve. One was the inability of deploying, legacy firewalls in modern architectures. I mentioned containers and serverless. and orchestrated containers in the cloud and things like that, where simply impossible to deploy an appliance, sometimes even a WAF as a service, a firewall as a service in the cloud. It's not something that you can sort of bolt on these kinds of new architectures. So we needed something that is cloud native by itself to support the cloud native architectures, to support microservices, support inspection of east-west traffic between microservices, things that you can't really do with traditional, legacy firewalls like appliances or virtual appliances. So that was one of the problems that we wanted to tackle. I'll get back to how we solved things in a second. The second problem was the auto-scaling nature of cloud-native applications. So you have containers, spinning up and down in serverless function, running and then disappearing. Instances, and so you can't really use something that is an appliance or a virtual appliance where you need to manage the capacity. You need to do capacity planning. So in a highly containerized environment, you might have spikes of traffic generating hundreds, if not thousands of instances, and so you can't really start adding more and more appliances to support this kind of spiky traffic. You need something that can scale up and down together with the application, with the serverless functions, with the containers. And the last challenge, I guess, is the fact that, and this might sound weird, but today we expect CISOs, the info security folks, to know, study, learn, procure dozens of security solutions, even if we just talk about cloud security. So you have cloud security posture management, and you have IAM security and DLP in the cloud and scanning of VMs and whatnot. And you can't really expect them to buy many point solutions from many different vendors. And we look at this fragmentation as a serious problem in the cybersecurity space. And we wanted something that will be all-encompassing, a one-stop shop for all of your cloud security problems. And so we decided that building WAAS into Prisma Cloud would make a lot of sense. And WAAS answers all of those, or tackles all of those challenges. First of all, it leverages the Defender agents that we already have our customers deploy as part of their cloud workload protection. So those Defender agents run inside every host, container, serverless function, VM, either in the cloud or on-prem, and they report back to the console where you can manage them, and you can manage them at scale. And so it's very easy for us to protect any kind of cloud workload because we are essentially attached to the workload itself. It doesn't matter how many instances you have, so there's no bottleneck or auto-scaling issues. The architecture is fully supported. We support, all the big cloud security providers. We support all the major, Kubernetes and container environments, and serverless, of course. And of course, we provide everything in a single place, so you can manage all of your cloud security needs in one place. And this module provides all the layers required today for protecting web and API against application layer attacks. So that's a web app firewall that inspects traffic intelligently and blocks attacks, bot risk management to fend off bots and automated processes, scrapers, etc. And also DOS protection and API protection. We allow our customers to load Open API or Swagger files and essentially apply positive security to the API, both north-south or east-west between microservices, which is something that I'm sure we'll get back to in a second. So that's the essence of the WAAS module as part of Prisma Cloud.
So tell us a little bit more about WAAS, the Web Application and API Security. I guess it used to be known as the Cloud Native Application Firewall.
Correct.
And so it's HTTP based, right? It's deployed directly on hosts, like you were saying, on containers, on applications embedded on serverless functions. It allows you to filter the layer 7 traffic to and from the application. It binds the applications running containers regardless of the cloud orchestrator. It allows you to, and that's true for the node or the IP address where it runs, and without the need to configure, any routing really. So for non-containerized web applications, you guys state that WAAS simply binds to the host where the application runs. And so that seems to be kind of one of the challenges here is, first of all, I mean, in context with this and what you're doing here, where do you find the most vulnerability for these new environments that you're seeing for that people are starting to deploy? What are the biggest issues that you're seeing face? Like, and what are the hackers like really going for? And so how does this WAAS principle apply to that?
Okay, so just to clarify, the Defender agent, which you mentioned, essentially it is deployed as part of your Kubernetes clusters on each node, on each VM, inside the serverless function, and basically hijacks the traffic going in and out of that workload, that microservice, for example. And after traffic is hijacked, it essentially, and hijacked in parentheses, of course, once we have the ability to look into the traffic, we're able to spot attacks, detect attacks, and block attacks, just like a web app firewall. But we live very close to the application. And this, in conjunction with the runtime protection that we also provide as part of the Prisma Cloud compute protection, which is, by the way, very interesting by itself because it learns the application, it learns the traffic inside your application between microservices, it learns which processes are running, and so forth, and it's able to generate a profile of what is good behavior for your application and enforce that behavior. And that allows us to go beyond the network layer inspection where we inspect layer 7 traffic and look for attacks like a regular web app firewall. If for some reason somebody managed to slip in some malicious code or a malware into a container, and that will start running and spawn processes, the runtime protection layer will also block that. So that's on top of the layer 7 web app firewall that you mentioned. But going back to what you asked, I looked today at the latest Verizon data breach incident report from 2020, and I found a few interesting pieces of information. One is that out of all the data breaches, 43% involved hacking web applications, which is mind-boggling. And over 80% of the data breaches, the hacking attempts actually included brute force or the use of stolen credentials, what usually people call credential stuffing and brute force attacks. And specifically, cloud assets were involved in close to 25% of all the breaches in 2020. Now, if you add to that the fact that I think the last I heard was that more than 80% of all web traffic today, and that came from Akamai, I believe, is now API traffic. And that's not surprising if you look at what's going on outside. You have mobile apps, you have all of the modern web apps communicate with APIs to the backend. You have east-west traffic between microservices. There's so much API traffic going on. And I wanted to say that it's just, it's about to explode in the sense that attackers are going to use that, but that's already happening. Some of the biggest attacks in 2020 involved APIs, and there's a good reason for that. It's very easy and convenient to protect the front end of web applications with a web app firewall, to scan them with vulnerability scanners like DAST and SAS, static analysis. But it's much harder to protect APIs, especially if you're looking at automated traffic. And this sort of brings us back to the bot risk management and why that's important today. Attackers discovered that API endpoints are much less protected. There's a lot less visibility around APIs. And all sorts of bot risk management solutions and anti-automation protections you can't really operate them on API endpoint because there's no user interacting with the API directly. It's not like the API is rendered in a browser. You can't put a CAPTCHA in front of an API because that wouldn't make any sense. And so APIs are becoming the, I guess, the weakest link or the thing that attackers look for first before they try something more sophisticated. And we've seen a few breaches recently and a few publications around APIs that were left exposed. Just a few months, I saw that developers left API keys exposed in GitHub and allowed attackers access to internal systems. And there was a famous doorbell, gadget, IoT device that you can install, which had a mobile app. I'm not going to name any names, and that exposed an API which allowed you to enumerate all of your neighbors and those that are not necessarily your neighbors. Right. And even our own, the Unit 42 research team, the Palo Alto security research team, published a few months ago a very interesting article about how you can abuse server-side request forgery, SSRF attacks, together with cloud metadata API in order to escape from containerized applications. It's a very cool vector because usually SSRF is something that sort of medium severity. It's not, you can't do a lot with an SSRF attack. Usually it means that the attacker can send HTTP requests out of the web app on behalf of the web application. But if you add to that the fact that the application is running inside a container in the cloud, now you have a situation where an attacker can launch requests, API requests to the cloud provider's metadata API, essentially stealing secrets, keys, account information, and so forth, which obviously escalates very quickly to losing your account and losing your assets. So APIs are definitely, I think, the biggest or the most interesting vector for attackers these days. I think I saw recently there was a login brute force attempt. The biggest one on the internet took place against the financial services login API with 55 million credentials being attempted within 24 hours. And obviously that's not something that's going to, start alerting people because most people don't monitor their APIs like they monitor the web apps. So definitely attackers are targeting APIs, and this is going to stay with us for a while.
So what is then bot risk management? What does that mean to you? So customers can manage the web bots and decide how to handle access from different bot types.
Exactly.
What are those different bot types, and and what is it that you do to provide that risk management?
Okay, so first of all, there's a good reason why it's called bot risk management and not bot defense, for example. You want to manage bots, or your customers or our customers, our users want to manage their bot problem. They don't want to block all bots categorically because there are good bots. You have the Googles of the world and, the Bing and whatever feed aggregators and website analytics bots, etc. So you want to allow the good bots in. You want to block or sort of push away the bad bots or the ones that are unwanted. Now, how do you do that? The good bots usually identify themselves either through the user agent string inside the HTTP request. For some of those you can trust, some you have to double check that they are indeed coming from the IP range or network or cedar blocks of their relevant companies. Those are what we call good known bots. Those are pretty easy to detect. They don't try to hide themselves. Then you have what we refer to as unknown bots, bots that you understand that they are bots. They don't look like humans, but you don't know their intentions. Could be API frameworks, development frameworks, clients, of all sorts. And then you need to allow the customer to manage how they want to react or to take, what kind of action they want to take. Do they want to block? Do they want to allow? Sometimes you want to slow them down, maybe raise a CAPTCHA challenge. And then you have all those bots that are trying to mimic human behavior. Those are the most sophisticated bots, and those are the ones that are really hard to detect and cause the most pain for our customers. Think about algorithmic trading, bots that do scalping for tickets. I don't know if you've heard, but it's a big thing now on the internet where bots buy new sneakers that come out. And then the people behind the bots would sell them for thousands of dollars. Those are limited edition sneakers on the internet, basically leaving us humans no chance of being able to participate in the commerce or the competition or those limited editions. And so with bot risk management, what we are doing is allowing our customers to choose how they want to react to the different type of bots, either based on signatures or based on more sophisticated active defense. So we present what's referred to as an interstitial page. We provide JavaScript challenges. We gauge the browser environment. We check all sorts of attributes. Is the mouse moving? Is the screen really there? Is the browser really the browser that it claims to be? All based on running all sorts of challenges and probes and fingerprints inside the browsing environment, and essentially detecting bots that try to mimic humans, and again, allowing our customers to choose how to, what kind of action they want to take with those bots.
So it really does require the user to manage their environments to be aware of bots much more and what is the weakness in the API endpoints that doesn't allow for that bot management?
Right. So as I mentioned, a lot of these protections require you to inject JavaScript into the page that is then rendered in the browser. However, in APIs, essentially the response is never embedded in a browser unless it's a part of some sort of kind of a XHR request, or it's just data that's then being used inside the browser. But most of these are machine to machine, B2B APIs, microservice to microservice, and so these are not the places where you want to inject JavaScript and wait for something to happen, because that's not going to happen. So you need different approaches. We can talk about micro-segmentation and application to application authentication and things like that, as well as enforcing API keys and rate controls and APIs and things like that.
So it's a whole nother level of really awareness that you need for the API endpoints that people haven't necessarily been paying attention to, because they've been focused more on really the static nature of the web, haven't they? Where it's less dynamic in terms of the API connecting all that, connecting all these different services.
Right. And if you think about it, one of the, and that's a motive that, a motive that comes back in every aspect of cybersecurity is the visibility, the fact that you don't know what you have. And today, when we are breaking down our applications from monoliths to dozens of microservices, sometimes running on different cloud environments, you don't really know which APIs you're exposing. And so part of the solution is, first of all, allowing our customers to learn about the APIs that they have, which APIs are not protected. And that's it's a small feature, but with a lot of impact that we are providing. On the radar view, if the listeners are, knowledgeable in how Prisma Cloud looks like, or the old Twistlock UI, there's a radar view that allows you to view your host and your clusters. We actually flag API endpoints and nodes or containers that expose HTTP endpoints and which are not protected by Prisma Cloud, and allow you to, with a single click of a button, start protecting them with the same solution that you already know. And so that's, I think, one of the coolest features that we have. It's a really cool visual indicator that you forgot some things. And I mentioned, the ability to load open APIs or Swagger files to protect your APIs, but in the majority of cases, we come to customers or organizations and we see that their open API specs are obsolete, outdated. They don't have all the APIs registered there. And so this visibility allows them to learn about rogue APIs or APIs that they weren't aware that require protection.
So one of the things that you find with microservices is that in container-based architectures, there is almost, in some respects, a lot more attack surfaces, but there's also some element of protection that comes with immutable infrastructure, where you essentially are deleting the prior container that you were using, for the service. And so in these environments, do the risks start to become mitigated just by the architecture itself?
I wish. Actually, I don't know if you remember, but back in the PureSec days, a couple, maybe 3 years ago, we published a white paper about how to exploit serverless functions to run Bitcoin mining processes. Something that you would think can't really happen, but exists. So the immutable infrastructure, the fact that everything is very ephemeral, is helpful. Serverless functions or containers are short-lived, does provide some sort of not protection, but things are less inclined to stay there for a long while, unless, of course, if you manage to find a way to exploit the node running the container. And we've seen more than a few vulnerabilities lately that allow you to do that. I just mentioned the SSRF, that even though the container is short-lived, you can still do a lot of damage. So yes, that is helpful. But as you said, there's a lot of there's an increase in the attack surface. You basically break everything up into many small components, which introduces complexity, which introduces bugs, which introduces more vulnerabilities. In addition, because those microservices can be written in different languages, frameworks, using different CI/CD pipelines, there's more chance to screw things up and to get something wrong. It's very hard to govern and control these very rich environments and very complex environments. Another thing with microservices is the matter of trust. We talked about that a little bit, but developers and who write APIs and microservices tend to trust one another as if they're living, in some protected bubble. But you should be actually practicing zero trust. You should be able to, or your microservices should be validating input from each other and not trust blindly. And you have to remember that malicious input can come, in many and from many different vectors. Obviously, not only HTTP parameters, and that's something that we saw with serverless. Functions can ingest input coming from S3 buckets or events coming from many different places, and you can't trust any of those.
Okay, so and then a follow-up question, and I want to get more into the news on the denial of service attack protections as you're offering. And you write that the denial of service protection includes the ability to defend against application layer denial of service attacks by applying rate controls.
Correct.
What has been lacking with denial of service attacks, and what is the importance of applying these rate controls? Clearly, the rate controls will help you think about, if the level of the attack, you can throttle that to some extent, I guess. But
correct. So rate controls are all about throttling and basically doing some sort of like a request accounting for clients. Now, historically, this was done based on IP. So you would count how many requests an IP does in a period of 5 seconds. Create an average, maybe look at longer time periods and say things like, okay, no client of mine or of this API should be sending 500 requests per second. That doesn't make any sense. I want to handle that. But the world is not as simple as that. And IP-based rate controls are flawed by design because you have many users coming from gateways, NAT gateways, what we refer to as shared IPs. And you don't want to punish users just because they share the same, IP or gateway with some, rotten apples. So what we did was switch or allow our customers to apply rate controls not only based on IP, but also based on the layer 7 session. So we track user sessions, we track the HTTP sessions themselves, the web sessions, and we count and we do the accounting based on the specific session cookie. Obviously, validating that customers don't drop the cookie or clients don't drop the cookie or manipulate the cookie, but that allows us to do a more granular work for the rate accounting, and we can prevent spiky traffic coming from malicious hackers inside NATed gateways, for example. Now, for all of the attacks that I mentioned, all of the protections inside WAAS also allow you to, you don't just want to alert, log, or block. We also provide a very cool trick, which we call ban, which is basically a penalty box. So once we detect that an attacker or a user or a client is doing malicious actions, users can decide to take action in the form of a ban, and that would put the malicious user on the side in the penalty box for 5 minutes. Now, it's not only annoying for the attacker that they have to stop every 5 minutes to continue with the attack, it's also a very cool protection layer, because most times attackers will not start with their most sophisticated attack payloads. They will start by probing, sending reconnaissance probes. And those probes will already trigger the ban action. We'll put them on the side for 5 minutes, and then it doesn't matter if then they pull out the big, the big gun or the big trick or the sophisticated attack. Those will be automatically and categorically blocked because they're in the penalty box, which again is a very good, defense against such attacks.
How do you do that? Like, I mean, we don't want to hear your secrets, but like, how do you do that? Like, how do you provide that service? What is it that you're doing on the other side of the fence, so to speak?
So the Defender agent that lives together with the application does the HTTP traffic proxying, as we mentioned. It does the TLS decryption, inspects the traffic, learns the parameters, the cookies, the user session.
Okay. And this is when you're looking at the browser version and all all the other information, and then you're
right.
analyzing that data then to provide real time updates, right? These are real time.
Correct.
And so this last question I have is about, as it relates to the news, is this about Creo. And we wrote about Creo, I think 2015 or 2016 when it first emerged. Why Creo? And for people out there who aren't familiar with it, it's a lightweight container runtime for Kubernetes. And so explain why you're adopting Creo here.
I think that's a benefit of not working for a startup anymore. You actually have real customers, real users with real pains. And we are constantly monitoring what our customers are asking for. And they are asking for a lot. The diversity of different environments that you see on the internet today is mind-boggling. And so this is a request that came from customers, just like supporting GCP and AWS and Azure and Alibaba Cloud and all those other clouds that we provide support for, and Docker and Swarm and Kubernetes and Istio. There's so many different environments and things that if you want to provide efficient protection for all of your customers, you need to be able to support all of those environments. And that's something that we are constantly monitoring and listening to our customers and seeing, what are the environments that we need to support. And based on that, we prioritize and release.
Are you contributing back to the Creo community?
Wow. I don't know. I should check.
Yeah, I'm curious because, it's an open source project, right? And, and a lot of companies are using the technologies, and I'm curious on how they're participating in the work as well.
Yeah, I'll check and I'll get back to you with that.
Awesome. Well, I think just in conclusion, I would just like to ask about, what does resilience then mean to you when it comes to API security these days? I've been very interested in this concept of resilience because I think it's really what the end user really wants. Even though they may not know it, they want to use a service that works. They don't want their password stolen. They don't want they don't want to be hacked. So what does resilience mean to you now in these days of API security?
Oh, do we have another hour? I'm thinking more from the eyes of a developer because that's where I'm coming from, or security expert, not from the user's perspective. So that's going to be, I guess, the direction that my answer is going to take. But we've heard the term zero trust being mentioned, I think, more times than we can listen to it. Zero trust is an amazing concept and is something very, very critical to the resilience of APIs and web apps and applications in general. But the way that we are architecting our applications today really dictates that we adopt zero trust between all components. Never trust anything or any kind of service. If you're consuming data from public services like public cloud services, never trust the data. Always authenticate, validate. The same applies for input. Never assume anything about those input, and think chaos engineering again, another term that we've heard a lot.
Yeah.
In order to build resilient applications, we have to go back to the basics. We've been talking about that for 20, 30 years now. Never trust any kind of input, never assume anything. Apply chaos engineering, try to break your applications before you deploy them. Obviously, apply application firewalling, which at this point is already a given. Add runtime protection. And of course, do all of that as part of your development lifecycle.
Right.
We're not 20 years ago. You need to scan vulnerabilities as you develop. You need to secure your configurations. We keep hearing, at least two times or three times a week about people leaving S3 buckets open still. I really don't understand why this is still happening. But scan your configurations, your infrastructure as code files. Basically, defense in depth. It all boils down back to the basics.
And you need to be aware of the next dimensions of it, such as in bot management, where you have very sophisticated bots mimicking human behavior, as you were talking about earlier.
But that takes you back to secure design. So if you design your application securely with understanding that not only humans are going to try to access it and maybe expose certain APIs for dedicated for bots and automated processes and not mix them together with your user APIs, that would have more chance of being resilient to attacks.
Well, I'd love to ask you more questions, but I think we're out of our time right now. But I think I got a good idea about what you're announcing here with web application firewall and these other related updates that you're making. And so thank you very much, Ory, for your time today.
Thank you. It was a pleasure.